Welcome learners for the lecture 14 of a linear algebra. Today we discuss about the some topic that will be the theorem is depending upon the one to one or the on to theorem. They will be getted as a depending on the vector transformation. Okay, let us go started as a theorem. Theorem is consider let V and W be the vector spaces and let T V tends to W be the linear. They will be considered as a some important statement, that is the T tends to V consider as a W be the linear. Then T is a one to one if and only if NT equals to 0. Means a null space is considered as a T transformation. Means a Laplace form will be considering in the null spaces, that is the NT equals to 0. Okay. What is this unit consider? That is, this unit is a linear transformation and matrices will be generated. Okay. Let us go started proof of this theorem. All of this given to that example. Let V be the vector spaces, V and W be the vector spaces. They consider T is a linear for the one to one. Suppose that T is a one to one. What is meant by one to one? If suppose we given as a T to R to the power n to T to the power m, at at consider as a most important concept is generating as a one to one form of the vector spaces, that is a one, at least one most vector spaces is considering as a r to the power n to generating as a factor, that is a r to the power m. N and m is generated at most of the vector spaces is considered. Okay, hence they will be considered as a x is an elements of a nt, means all x will be generating is an elements of a nt. Then Tx equals to 0 means x equals to 0, because considering to the value means t 0 is generated. Since t is a 1 to 1, we have x equals to 0, hence nt equals to generated as a 0, because nt is generated as a x elements for the value. Now we assume that nt equals to 0 and suppose that tx equals to ty, means the two elements will be considering x and y coordinate they generated. Then x equals to this ty is generated that side, that is the tx minus ty equals to 0, means t is a common, x minus y equals to considering as a 0 by using to the property in the first part of this second unit. We already clear to the concept of that if we generated as a common of the t, then it will be generating as a x minus y by the using as a property. Therefore x minus y, this is also elements of the nt, because t is generated as a 0 for considering to the value of a x. Then x minus y is an elements of a nt, that will be equals to 0. So x minus y equals to 0 or x equals to y will be generated. This means that t is a one to one form of that consideration. Okay, this is understand for the part. Definition, another topic will be generated using the notation about, we call the m into n matrix a defined by the aij equals to small aij, the matrix representation of a t in the order basis beta and gamma will be generating to the form to write to the matrix of the notation a equals to t to the power beta in the base position and gamma is the power position. If v equals to w and beta equals to gamma generated, then we write a equals to 2, beta will be considered for giving to the this value. Okay, example third will be generated. Okay, let us go start it. Let t tends to r square to the r cube. This is n m be the linear transformation defined by t a1 a2 minus a1 plus 3a2 0 and 2a1 minus 4a2. Let and y be the standard ordered basis for the r square and r3 given to the value is generated for the transformation. Now we consider as a t is generated as the value 1 0 equals to 1 0 order basis for the r square and r cube respectively. Now t10 equals to 102 equals to generated to the value e1 e2 and e3 for the basis of their value and generating to the part. Okay, they will generated as a form, that is the 1 e1 0 e2 and 2 e3 for the part. T generated as a 0 1 equals to 3 0 minus 4 will be generated. when putting to the value of a 0 1 means a1 is considered as a 0, a2 considered as a 1 means only put it as a value 3, second is already as a 0, and third will be generated as a a1 equals to 0, this is 0, and a2 equals to 1, that is a minus 4 will be generated. Then 3e1 plus 0e2 minus 4e3 will be generated. Same as this part also will consider to the form, that is a 1 0, this is 1, this is 0, already 0, this is 1 means only 2, and this is a 0. They solving to the problem for the 0 1 and 1 0 in the form. Then hence generated to the value of this part in the column transformation as well as the row form of the value. Okay, t beta alpha is generated to the form 102 30 minus 4 of the basis of their value. If we let gamma equals to e3 e2 and e1, then generating to the part of this value, both of this condition for changes to the part of this value, they will be row is considered as a column, row is considered as a column, and column is considered as a row, means 201 and minus 403 will be generated to the form. Okay, this is the solution of this theorem. After that we uses to the another definition. Let t consider as a u to v consider as a w, means let t u tends to consider v tends to w be the arbitrary function where v and w are the vector spaces over the field f, and let a is an element of the function f. We define t plus u generated to the value both of this function considering to the by equation t plus u x equals to generated as a t separated tx plus ux for all x's and elements of. If we multiply to the form of alpha, then generated to the part alpha is a common, tx will be considering for all x's and elements of v. All of this is considered as the definition as well as property of this function. These are just to the usual notification of the definition of the addition and scalar multiplication of this function x considered as a alpha is multiplied to the form of this linear, hence it is called as a multiples of a linear transformation of the vector. Okay, let us go next theorem. Let v and w be the vector spaces over the field f, and let t to consider as a v to w be the linear. First part will be generated for all alpha is an element of a function, alpha t plus u is a linear. First part will be solved, and second is using the operation of addition and scalar multiplication. In the preceding definition, the collections of all linear transformation from v to w is a vector spaces over the field f. Let us go start it. First we solve to the form, let xy is an element of the v and c is an element of the function f. Then first part will be generated to the part alpha t plus u consider as a form, that is a cx plus y to generate this part. Then equals to alpha is multiply of this both of this function. First of all, this function will be generated to the part cx plus y is multiply alpha t plus you consider as a cx plus y. Then common to the part alpha, in that position t is multiplied to the these two part will be generated of the value. Okay, then alpha c consider as a common tx plus ty generated plus c consider as a ux plus uy will be generated. Then a consider ac common, tx plus c consider as a ux plus alpha ty plus ui. Then after that c is a common, this both of this part alpha t plus u, x is a common plus same as a part generated to the value, that will be the part alpha is considered as a form, y is a common, alpha t plus u will be generated. Both of this function is the same, means alpha t plus u is a linear part, this linear part noted as a this is linear. Then next is a b position, nothing that the t0 the zero transformation play the same role for the vector spaces. They show as examine to the vector spaces as well as a collection of all linear vector from the v to w into generated to the value of the vector space over the field f. Then this value will be generated to the bar. Okay, vector field of the collection is generating to the all this part for the value will be generated. Let us go next theorem. Let v and w be the finite dimensional vector spaces with order basis beta and gamma respectively, and t consider as a v to w be the linear transformation then generated to the value in both of these function t plus u beta and gamma equals to same as they operated to the form in a separate position, and alpha t beta to gamma equals to alpha is a common t to the power beta gamma for all the scalar of a. Then proof of this condition generated to the form in a basis of the form, let beta equals to v1 v2 vn and gamma is considered as a w1 w2 wn. Beta and gamma is generated. There exists as a unique scalar aij and bij considered as a 1 is less than or equals to I less than or equals to m will be considering. Okay, same as a two part of a j, n will be generated 1 to n such that two part will be generating to the value that is considered to the tvj equals to m will be considering to the part I equals to 1 aijwi is considered as the same as the j position of this part will be considered. This is generated as a t of v and another part I equals to 1 to k bijw is generated to the value for I is less than or equals to j is less than or equals to n. Then solve to the equation to put it to the value of both of this equation. T plus u consider as a vj equals to same as a position t plus u is generated to the part wi is a common in both of these condition, that is a summation I equals to 1 to m is generated aij plus bij wi considering. When we using as a beta and gamma to the position, then as to show to the value of aij plus bij considering to the value these both of this condition to the ij. Okay, this is the proof of this first part of this position. Okay, let us go b part. Same as a proof of the b position for changing alpha is giving to the form t will be considering. Okay, this is a getting as a solving to the problem, same as a step we uses to the